and I would like you to build, we go back here to time task, I'd like you to build the code for the ball intake. So go and copy an actuator loop and fill it all in, and turn on the left and right motors and control them in some way. For instance, you can control them the same way here. We can use button 1. This is all going to be moved up to teleop here. We're reading the buttons up in teleop, and we're going to write to a global variable that will make these motors run. So notice the code that one runs forward and the other runs reverse. Make sure that works in your code. And then once you create the loop, put the loop in time tasks like we did here with the drive, and then test it and kind of zoom into your robot and make sure that the motors are spinning the opposite direction, and then see if you can intake a ball into your scoop. All right, so go ahead and pause the video and build that loop, and I will build it as well, but I'm going to build it super fast with the video sped up so we conserve a little time, and then when I'm done I'll come back and talk it through with you. So brief pause here. I used the LabVIEW graphics to quickly draw up a state machine. And again, the way you do that is all the decorations are on the front panel. So you have to have the front panel. You pull off the decorations off the decorations palette, and you can actually pull them onto the block diagram. So I pulled circles and some arrows, and then if you double click in blank space, you can create a free label, and then shift right click and get the paint tool, and I can color them. So startup, we immediately go to idle, but we send the stop intake action, and then we look to see if our enable is true or false. If false, we continue stopping the intake. If we are enabled, we go to running, and if we're still enabled at running, we run the intake action, and that's just going to take the speed control from the command and send it to the motors, and we keep in running until enable goes false. We stop the intake and go back to idle, and here we look for global stop, and we should have another arrow coming from idle to shut down with global stop true. All right, I will continue. I will now implement this state machine for my state cases and my action cases. Okay, so I've completed the intake actuator code, and let's review. So I ran through that very quickly. I sped the video up pretty fast. So what I'm going to do is I'm going to create a separate video that just shows me doing this in real time. So those that want to review or follow along slower, I'm going to have a slower version of video just creating only this state machine. But let's review, go through it. So at the beginning we open our two motors, our left and right motors. They are PWM 7 and 8. We had to create constants to put in our cluster so we could bundle those two in. We created a command cluster here from that teleop or autonomous will write to command the intake. And in there is two items: the speed, which is the 0 to 1 value, tells how fast we want to spin our intake motors, and an enable button that will turn the intake on and off. And we built a state machine with 4 states and 2 new actions. And there's our state machine. And here are our 4 states. Startup. We immediately go to idle and we do a stop intake action. Idle, we look at our command, enable, and if it is true, we go to the running case, and if it's false, we stay here in the idle case and we continue to send stop intake. If we are running, again we look at the command. If it's true, we stay here in running and we send the run intake action, and if false, we go back to idle and we set the stop intake action before we get back to idle. And then we have a shutdown. Continuing shutdown, that will shut down the loop anyways, as we will send a stop to our loop, and our last action will be stop intake. And for our actions, we have our basic 3 that we always just keep there because they may be useful. For stop intake, we set our motor speed to 0, and for run intake, we read the speed from our command global cluster and we write it to our motor speed 1 to 1. If our motor goes backwards or does the opposite of what we want, we could invert this number, or we could invert it here at our set outputs, whichever. We have to test it to know for sure. And then our last section, we write all our outputs. So we set our motor values. One we run one direction and one we run the opposite direction at the same motor speed. And then we write those values, output values that the motors are running at, to global variables because somebody may want to read those. And we put them back, all these items back in our cluster. And then we also run a bunch of displays here for our front panel. So if we're trying to debug, we can quickly open this front panel and we can see what our values of our intake are. And if it's supposed to be enabled and it's not, we can see that as well. And then finally, when the loop stops, we close our motors. Now the other code did not close the motors, so to find those motor close, we have to go to our library and robot drive, and then there's a motor folder here, and with all the motor direct motor VIs, and there's your motor close. And the last thing I want to do is create an icon.